Hey guys, we're going to brush up on what it means to be a function in this section, and I want you to understand what the definition of a function is and what some characteristics of a function are. So obviously those are going to be our first two objectives. Know the definition of a function, know the characteristics of a function. In the next video, the objective is going to be to figure out how to determine the domain of a function. So before I get into the technical mathematic definition of what a function is, I'd like to kind of make an analogy, and it's this. Think of a function as being a post office. Okay? Post office has a bunch of letters, which we'll call X, and they need to be delivered to a bunch of mailboxes, which we will call Y. Okay? It would act as a function only if every single letter ended up delivered to a mailbox and no letter was delivered to multiple mailboxes, which should make sense because I'm not talking about things like junk mail where everybody gets one. I'm talking about one specific letter cannot be delivered to more than one mailbox. Okay, and in addition to that, you should know that a mailbox could receive more than one letter, and some mailboxes may not get any letters at all. Okay, so this will all kind of make sense as we go through the characteristics. But the technical mathematical definition of a function is a function f from set A to set B is a relationship that assigns to each element x in the set A exactly one element y in set B. Okay, set A is the domain of the function, and set B is the range of the function. Okay, so basically the post office is set A, and it's full of letters X. The mailboxes are set, or the citizens of and residents of the town is set B, and they have mailboxes. Okay, so that is the technical definition. Now, characteristics of a function are as follows, and I'm going to go through these characteristics. There's a total of 4 of them. I'm going to go through them one at a time, and I'm going to bring it back to that post office example that we did. Okay, so the first one is every element in A must be matched with an element in B. Okay, so with the post office example, this is what it would mean. And first of all, let's label the post office example. The post office, as I said before, is set A, and each of the letters is an element X of set A. The town residence is set B, and the mailboxes are an element Y of set B. Okay, so going back to that previous example, or that characteristic, every element in A must be matched with an element in B. So what does that mean? That's like saying that every letter must get delivered to a mailbox. Every letter must get delivered to a mailbox. Okay, characteristic number 2. Some elements in B may not be matched with any element in A. That's the same thing as saying some mailboxes may not get a letter delivered to them. Kind of like me on Valentine's Day. I don't get any notes. Everybody else does, not me. Third characteristic. 2 or more elements in A may be matched with the same element in B, which is like saying some mailboxes may get more than one letter sent to them. And the fourth one, an element in A cannot be matched with 2 different elements in B, which is like saying the same exact letter cannot be delivered to multiple mailboxes. it can only go to one mailbox. Okay, so hopefully that makes sense. It sounds more complicated than it really is, and what I'm going to do now is take a look at a basic graph to illustrate the characteristics that we just talked about. Okay, so here we have a parabola that's on the graph there, and one by one I'm going to go down that list of characteristics, and you'll see that it holds true for this particular example. First characteristic was that each element in A must be matched with an element in B. Okay, so in this, since we have a number line on there, what we talk about element A being is all the x values on the real number system, in the real number system. Okay, our graph doesn't show them all. Okay, this one goes from -10 to +10, and in fact the red graph that you see, it doesn't even look like 4 has a value, but as you know, 4 does have a value. It just happens to be far off of the graph. So every x will have a corresponding y value, so characteristic number 1 is good. Characteristic number 2, some elements in B, some y's, may not be matched with any element in A, may not be matched with an x. Okay? So if you take a look there, there's a whole bunch of them right there that do not have a match. Those y values do not have a match in x, which is perfectly fine. All the x's must be assigned to y, but not all the y's may be. Third characteristic, 2 or more elements in A may be matched with the same element in B. What I want you to take a look at is on the graph where x equals 0 and also like around -7.2. Look at those two spots. Because if you follow an arrow up, you'll notice that they both correspond to a y value of 8. So I have 2 different elements in A being matched to the same element in B. 2 different x values go to the same y value. And the last one, an element in A cannot be matched with 2 different elements in B. Okay? In the next chapter, or not the next chapter, the next section of chapter 1, we're going to go over a rule for looking at a graph and determining whether or not it's a function. But right now I just want you to think and follow along that curve. Are there any x values that have 2 separate y values associated with them? And if you follow along that curve, the answer is no. Okay? When x equals 4, right there, there's only one value that it corresponds to. When x equals 0, there's only one value it corresponds to. Okay? So that's what we mean by that. And in the next section we're going to talk about the vertical line test, which is a real simple way of determining whether or not something is a function. Alright. Now that you know how to determine if a graph is a function, how would you be able to do it if you were looking just at an equation, you didn't have the graph to go along with it? Okay? Surely there's some way that we can play with an equation to determine whether or not it counts as a function. Okay? What you need to do is solve the equation for y, which means get it in y equals form. And if y is equal to one function of x, that's good. That means it's a function. If y is equal to multiple functions of x, then that's not good. It's not a function. So my guess is that you're probably asking yourself, how in the world can y be equal to more than one function of x? And your answer looks like this. If my formula starts off 3x squared plus y squared plus or equals 24, and my job is to solve for y, okay, first I bring that 3x squared to the right hand side. Then I have y squared, and how do I get rid of y squared? I have to take a square root. However, if you remember, something like if I were to ask you what the square root of 9 is, the answer isn't just 3, it's plus or minus 3, because a negative 3 times a negative 3 is also positive 9. So remember, when you take a square root, you have this plus and minus value. Okay? That's two different functions. There's a positive version of it and a negative version of it. Therefore, that does not qualify as a function. Okay? So really that's all there is to know about the definition and characteristics of a function. So that's the end of this video. Adios.